Given an array of strings, design an algorithm to return the number of groups of strings that are spatially equivalent. That's about today's video. Let's dive in. San Francisco Bay Area, or Silicon Valley. This is where my dream started. Hey everyone, this is Steve here. Today we're going through another LeetCode problem. LeetCode 893, groups of spatial equivalent strings. Let's take a look at the problem first. You're given an array of A, which consists of strings. A move on to S consists of swapping any two even index characters of S, or any two odd index characters of S. What does that mean? Let's take a quick look at the example. So here, example ABCD, given all of these strings. One possible group is ABCD, or CDAB, or CBAD, since they are all pairwise spatial equivalent, and none of the other things are all pairwise spatial equivalent to this. Let's just go through the problem description. For example, here, ZZXY and T, XYZZ are spatial equivalent. Why? Because if we make such two moves, to basically swap the odd index characters with odd index characters and even index characters with even index characters. Let's see, ZZXY. We are going to swap what? ZZ. How come ZZXY becomes XZZY? It's because we swap this Z with X. Why? Because this is index 0, this is index 2. They are both even index based characters. So that's why we swapped these Z and X. So it becomes XZZY. So it becomes XZZY. We swapped even based index. And then we can further transform this string into this. Why? Because XYZZ, how does the Y come from? The Y comes from the last character. This is at index 3. Index 3 could swap with odd-based index, which is 1, right? Here is 1 is Z, so it becomes XYZZ, here, XYZZ, which is exactly T, which is another string, XYZZ, here, right? That's why we see the problem says ZZXY and XYZZ, they are spatial equivalent. That is why. Okay, the question boils down to how do we design an algorithm that can spatially uniquely represent to form a very unique string that could be a representative of all of the spatially equivalent strings. One solution is to use, we can just count the frequencies of all of the characters that are at odd indices, and all of the frequencies of the characters that are at even indices. That way we can just concatenate these two arrays, and then that's going to be the spatial unique most representative string of this spatial equivalent group. That's the algorithm. And before we start coding, there's a bit of confusion about this problem. Actually, I encountered this confusion as well. My very first solution that I submitted it returned me a wrong result because I thought the problem is asking us to return the maximum number of the max group that has the maximum number of spatial equivalent strings. For example, in this case, it's this group with 3 strings. That's why it's output 3. But actually, that's not the case. See, there is another explanation sentence here. It says the other 2 groups are this and this. So it's asking us to return the total number of groups of spatial equivalent strings. That's why this one is 3. It just happens to be this one. It contains the max, and it contains the number of strings, equivalent strings that it contains is also 3. So I saw on Discuss board there's such a confusion, which I was confused by this problem as well. But anyway, let's come back to this problem. As we just said, we'll just find a way or an algorithm to compute a unique representative for this spatial equivalent group. That's it. And from there, we can just go through this array and keep comparing to see whether we have such a representative already. If we do, we'll just we can build a hash set. We can use a hash set to keep adding for every single string that we go through in the given array list, we'll just put that represented into this hash set, because hash set guarantees all elements added in is distinct. So then we can just finally we can just return the size of the hash set. That's it. With that said, let's start writing the code. We'll initialize a hash set. It's going to be a string type, which we're going to compute a representative string. Set new hash set. Then we'll go through every single word, every single string. String, is that right? Yeah, string. Okay. String, and then we'll have two integer arrays to help us keep track of the character frequencies for both odd indexed characters and even indexed characters. That's why we have two integer arrays. We'll just call it odd. Since it says all of the letters are lower English letters, so we can safely just use 26. If it's not given, if we were not given such a node, and you get asked in the real interview, you might want to clarify this with your interviewer whether this is a possible approach. Otherwise, we can use another algorithm. I have my solution 1 in my GitHub link, link in the description below, so feel free to check that one out. And then what we'll do is to come back here and do this, and then we'll go through. So the outer for loop is to go through every single word in the given array list. And for the inner for loop, we'll go for every single word that we're iterating on. We'll go through every single character that form this given string. So we'll start from I is smaller than string length I++. What we'll do is check whether this I is at an odd index or even index. Is modulo 2 if it's 0, then we know it's at an even based index. What we'll do is even string char at I minus a. So we know we can increment the integer at this position, plus. We can increment it. Otherwise, we'll just increment the one at the odd position. That's it. And then in the end, what we will have is we'll just compute a special key as the representative of this array. What we'll do is arrays to string. This is a handy API in Java, array. Odd plus arrays to string even. And then we'll just add this representative into the hash set. Add key. Finally, we'll just return the size of the hash set. That's it. That's the algorithm. Let's hit submit and see. Yeah, it's accepted. Faster than that's pretty slow. Let's submit it again. All right, it's like this, 12 milliseconds. Memory usage, 100%. That's fine. Yeah, a big shout out to this guy, Java Concise Set Solution, Kara Singh. Yeah, this is the algorithm. Credit to him, big shout out to him. I didn't come up with this solution originally, but as soon as I saw that, I thought this is really brilliant. The solution that I come up with is on my GitHub, so feel free to check it out. Which I think is more generic, which is not bound by this node. It can be any characters. I mean, this one we can extend it to like 100 or 128 or 258 to be more inclusive as well. But anyway, the idea is the same. Is to basically find an algorithm to construct especially a representative key for this string, so that we can group all of them into the same one, or just add this representative, this unique representative, or globally unique representative into this hash set and return the size of the hash set. That's it. I hope this makes sense, and if you learned something out of this video, please do me a favor and gently tap that like button. That's going to help a lot with the YouTube algorithm. And also don't forget to subscribe to my channel as we continue to go through a lot of LeetCode problems. I'll see you guys in the next video.